All right, find the indefinite integral. The difference between that and a definite integral is you see that there are no limits of integration. Okay, there's no bounds. On a graph, it's not saying from an A to a B. So whatever the graph looks like, let's just say we pretend it looks like that. It's not saying between a specific interval. It's not really looking for that displacement. It's just looking algebraically, what is the antiderivative of each piece, and then do plus C. Okay? So, t to the fifth. Okay? And again, like I said, because there's subtraction between these islands, if you will, you can separate them and then subtract there at the very end. Okay? So, what is the integral of t to the 5? What do we do first? So we're going to add 1 to the power, right? So it'd be t to the 6 divided by what? 6, the new power. So t to the 6 over 6 is the answer there. Without looking at anything in red, no negatives, no nothing, what's the antiderivative of cosine? Sine, right? The antiderivative of cosine is sine, because we learned from first semester that if we derive this, it would be a positive cosine. This is where a lot of mistakes happens with negatives. For a whole semester, you've been used to going forward to a positive cosine. Now you're learning from a positive cosine to go backwards to a positive sine. And when you finally get used to going backwards, to here at the end when we're reviewing for the AP exam, you got to learn how to go forward and backwards immediately without making those mistakes. So it's a lot of practice, a lot. Okay, the subtraction does come down, and what am I still missing? Plus C, right? Could I put minus C and still get it correct? No. I still could, because cosine is still, no matter what, or sorry, cosine, C is a constant. So whether I'm adding it or subtracting it, when I take the derivative, it's still going to be what? 0. Don't put that. That's not kosher or whatever, and I don't know what sign will give you credit for if you put minus C, but it should, because C doesn't matter what it is right now. Okay? So t to the 6 over 6 minus sine of t plus C, and there's your answer. Yes?
So we don't change the sign when we go from cosine to sine?
Okay, let me
just brought down the negatives, so like we're not changing.
So be careful with what shortcuts and what identifications of memory that you program your brain with right now. Because it can be jacked up and it can be messing up a lot of other stuff that's about to come. My best suggestion to you is this. Rememorize the fact that sine's derivative is cosine, cosine's derivative is negative sine, and tangent, anyone, is what? Secant squared. Okay, so check this out. This is a good question, good timing. If I'm taking the antiderivative of cosine, what would it be? Sine. But, and his question is looming around this fact. What if I took the antiderivative of a negative cosine? Okay? If I'm taking this, what do you think the antiderivative is? Negative sine. And if you don't see it easily like that, you can always pull this negative out, constant multiple rule-wise, and create what you've identified from the chart of the antiderivative of cosine. This piece will be a positive sign. The negative constant multiple rule gets brought down, and it's still a negative sign. That's huge right there, because that's where all the negative mistakes happen with all the trigonometrics, because they're everywhere. And then when you're subtracting negatives and all this other stuff, it's going to be very upsetting if you don't carefully manage those negatives.
All right.
And my antidote to that is constant multiple rule, if you struggle with that. Okay? Any other questions on this one? So C plus t to 6 over 6 minus sine of t. Yeah, you could put C in the front if you want. It doesn't matter because you're adding it anyway, and addition has no order. Okay.